Hi everyone, my name is Ms. Baratko, and today we're going to talk about ratios and proportions with real world context. So we've done this a little bit throughout the week using Egyptian units of measurement, using problems about the goldfish, and so on and so forth. So we've used a couple examples to help us really understand ratios and proportions in real life. However, today we're going to go a little deeper. I want to really clarify the use of tables and equivalent ratios to help us relate quantities. So using a ratio table is going to be a great tool for us to compare ratios and really make observations that we wouldn't be able to do off the top of our head without a table. We're also going to solve unit rate problems and think about things such as having miles per hour or distance per second, right? Rate has to do with having a denominator of 1, and when we have a ratio that has two different units. We're going to be finding percents of quantities and also using ratio reasoning to convert measurement units. So we've done this a little bit, most specifically with our goldfish problem, but overall, we want students to use ratios in a real-world context to manipulate ratio tables to find unit rate, percent of a quantity, and convert units of measurement. So what is a ratio table? Well, a ratio is a comparison between two or more numbers or amounts. So a ratio table allows us to view numerous proportional relationships and to isolate significant data. So for example, we can figure out the unit rate, the percentages, and we can also compare that data, for example, figuring out the best value of a product like we did in the goldfish problem. So one real world ratio we can really think about, seeing as it's the holiday season and it's supposed to be getting chilly soon, is making hot chocolate. So let's say Starbucks uses a cocoa to water ratio of 3 to 4. That means for every batch of cocoa, we're using 3 parts cocoa and 4 parts water. Dunkin' Donuts uses a cocoa to water ratio of 4 to 5. Whose hot cocoa is going to be the most chocolatey? And we're going to use a ratio table to help us decide. So in the ratio table, we know specifically that comparing Starbucks and Dunkin' Donuts hot chocolate, we want to know what is going to be the most chocolatey. Well, one way to start is to think about what do I need to be a constant factor in my equation, in my recipe, in order to really determine who has more cocoa powder. So for example, if I have 4 cups of water in my Starbucks recipe and 5 cups of water in my Dunkin' Donuts recipe, I'm starting out with different amounts of cocoa. I'm starting out with different quantities. So I really want that base of the hot water to be the same, and then I can add my cocoa and decide which is more chocolatey. So in order to make the same base, we kind of need a least common multiple of 5 and 4. And that's because those are our quantities of water. So the least common multiple between 5 and 4, if we listed all the multiples of 4, it would be 4, 8, 12, 16, 20, 24, 28, 32. We could go on and on. But I know that there's also a multiple of 5 that I just listed, which was 5, 10, 15, 20. So when I am at 4 cups of water, I can very easily convert to 20 cups. When I'm at 5 cups of water, I can very easily convert to 20 cups. How am I going to do that? Well, 4 times 5 would give me 20, and 5 times 4 would give me 20. So now whatever I did to my amount of water in my hot cocoa, I also need to do to my amount of cocoa. So because I multiplied by 5, I'm going to multiply by 5 again and say 3 times 5 is 15 parts cocoa. And then the same thing for my Dunkin' Donuts recipe. Because I multiplied by 4, I'm going to multiply by 4 again. And I get 16 parts cocoa. Now, my total amount of drink is 35 cups in my Starbucks recipe and 36 cups in my Dunkin' Donuts recipe. So those are actually pretty close overall liquid quantities. However, my important thing is that I'm starting with the same amount of water, because now I can look at the amount of cocoa and decide which has more. Well, when I have 16 parts cocoa in my Dunkin' Donuts recipe and only 15 parts cocoa in my Starbucks recipe, that means that for the same amount of water, my Dunkin' Donuts recipe actually has more cocoa powder than the Starbucks would. So that is going to be the most chocolatey hot chocolate. Another cool thing to think about when you are using ratio tables is that a really nice thing to do is to always include your unit rate, and that means out of 1, right? So if I have 1 part water, how much cocoa am I going to have per cup of water? So I always like to leave the first column in my table blank so that I could put my unit rate in that column, but it is going to be a little complicated because I have to work backwards. So I'm just going to insert some workspace and hopefully show you. If I'm starting at the 4, I need to be able to divide by 4 to get to 1. 4 divided by 4 is 1. So I'm going to be dividing by 4, whoops, in kind of a backwards direction, and that's going to equal 1. So in order to do that with my cocoa powder, I need to divide by 4, and that's going to equal the amount of cocoa that I put in my cup. So 3 divided by 4, I could say is 3/4 part cocoa, but I know most of you prefer decimals, so that's 75 hundredths of cocoa powder per 1 cup of water. Now I did use my calculator to do that, and you may do the same. Whenever in a ratio table you don't have a clear proportion, you're welcome to use your calculator. So the same thing in my hot chocolate, my Dunkin' Donuts recipe. If I have 5 and I need to get to 1, I'm going to divide by 5 to equal 1. And then for my cocoa powder, I'm going to divide by 5 to equal 8 tenths or 80 hundredths per cup of water. So again, I'm going to have 80 hundredths of cocoa per cup of water, and that's going to be my unit rate. Another good thing to do when you're looking at ratio tables is to think about percentage. So what amount out of 100 am I going to get for my ratios? So to get from 20 to 100, I'm going to multiply by 5. I do the same thing in my cocoa recipe. So 15 times 5 is going to give me 75. In my Dunkin' Donuts recipe, 20 again times 5 would be 100. So 16 times 5 would be 80 parts cocoa. So in my Starbucks recipe, the cocoa makes up 75% out of 100 of my drink, and in my Dunkin' Donuts, it makes up 80% of my drink. So conclusions about hot chocolate. When I calculated my recipe in proportion to the original, I was able to decide which drink was the most chocolatey based on setting the quantity of water equal to each other. So both drinks had the same amount of water. Which one was going to have more chocolate? That was going to be the most chocolatey. I can also use the ratio table to convert the recipe to serve a larger or smaller group of people, right? Notice I included this row that said drink, and it was really the sum of the cocoa and the water together to tell me how much hot chocolate I was going to make total. So I would know that if I needed a lot of hot chocolate for a large group of people, I was going to use a certain proportion of chocolate to hot water to get the right flavor. Ratio tables are really important in understanding ratios and proportions because it allows us to view a lot of data at once and really make some great observations and conclusions based on what we're learning from our calculations.